Hello everyone, this is Ramon Mars and today we're starting a new channel, specifically a physics channel. This channel specializes in IB physics and is meant for SL and HL physics students. So let's get started. Today we're going to look at chapter 2 and subtopic 1, motion. In this video we're going to talk about distance and displacement, speed and velocity, acceleration, average and instantaneous, motion and uniform acceleration, free fall, motion graphs, and projectile motion. If you are just starting IB physics, you most likely already know these definitions as they came up to in pre-IB courses, but we'll still run through them just to make sure everyone's on the same page. So distance is how far something has traveled without regard to direction. We use the word distance in everyday language, like let's say I traveled 200 meters to get to the grocery store. IB likes to use the word displacement more often than distance, and displacement is how far something has traveled with regard to direction. So when you're talking about distance, you don't need to mention direction. On displacement you must, as is some vector. Let's look at an example. In this situation we have movement A and movement B. In movement A, the red ball moves on a line 15 meters to the right, and in its move B it moves 20 meters to the left. The total distance traveled by the red ball is 35 meters, 15 plus 20. However, its displacement is 5 to the left. It's important to indicate the direction, as displacement is a vector and must contain a direction. Formula used for displacement is delta x equals x2 minus x1, or s equals x2 minus x1. x2 is used as the final position and x1 indicates the initial position of object in discussion. In IB formula book, S is used for displacement and it will be used throughout chapter 2, not only this video but the following videos as well. Now let's talk about the difference between speed and velocity. Velocity is the measure of how fast an object moves through a displacement, or simply put, the displacement divided by time, and is measured in meters per second. Just like displacement, velocity has a direction and that direction must be indicated. The formula used for velocity is v equals delta x over delta t, or v equals s divided by t. As you can see in the first formula, for people who have already studied calculus, they can notice that velocity is a derivative of position, or x. Speed, which also is indicated by v, is a measure of how fast an object moves through a distance, and like distance, it does not have a specific direction, or it can be said it's a distance divided by time, and it's also measured in meters per second. IB uses variable u for initial velocity and v for final velocity. This will be important in our further slides and later videos. So now let's talk about acceleration. Acceleration is the change in velocity over time. A equals delta h over delta t, or A equals v minus u divided by t. Again, v is final velocity and u is initial velocity. Again, people who have already started calculus can see that acceleration in the first formula can be seen as rate of change of velocity, and hence a first derivative of velocity. Since velocity is a derivative of position, acceleration is the second derivative of position. Now let's look at an example. A driver sees his speed is 5 meters per second. He then simultaneously accelerates and starts a stopwatch. At the end of 10 seconds he observes his speed to be 35 meters per second. What is his acceleration? So let's label each number that we see in the example with a letter. So v, final velocity, is 35 meters per second. U, the initial velocity, is 5 meters per second. And t equals to 10 seconds. Then we use the formula a equals v minus u divided by t, as those are the variables that we have given to us. And we substitute and calculate. For acceleration to be 3 meters per second squared. Average and instantaneous values can be found for velocity, speed, and acceleration. Average speed and velocity is delta x over delta t, or more simply x2 minus x1, and average velocity is denoted by letter v with a horizontal line going through it. The horizontal line means its value is average, whether it's velocity or it could be acceleration. And instantaneous velocity, unlike average speed, or average velocity, which is self-intuitive, it's the velocity that is averaged through the time given. Instantaneous velocity is the velocity at a given point of time. In our formula we have v equals delta x over delta t. Delta t is not a specific point. To make this formula work for instantaneous velocity as well as possible, we need to approximate delta t to 0. So as delta t approaches 0, v in this formula will become instantaneous. Now let's talk about motion in uniform acceleration. In this section we'll talk about motion that occurs when the acceleration is uniform or constant. We can use the following four formulas in order to find one variable or another. These formulas are called kinematic equations, or sometimes referred to as Suvat equations, because they use variables s, u, v, a, and t, displacement, initial velocity, final velocity, acceleration, and time. These formulas are important because with limited information we can find a certain variable. For instance, let's look at the first formula. We have s, u, t, and a. In that formula we do not see final velocity or v. Hence, if we don't have v, we can use this formula if we know other variables in here. Similarly, all formulas have only 4 variables out of the 5 from the Suvat. The second one does not contain displacement, third one does not contain time, and the fourth one does not contain acceleration. It's important to remember that these formulas work only when acceleration is constant or uniform. And these formulas can all be found in the IB Physics formula book, and hence you should maybe, if you want to, memorize them, but it's not a necessity because they are going to be on your final IB exam. Now let's talk about free fall. Free fall happens when you drop an object and it falls continuously without air resistance. Since objects fall, there's acceleration. They accelerate due to gravity. It is so important that we give it a variable g. All objects during free fall accelerate at negative g, where g equals to 9.80 meters per second squared. Sometimes that number is rounded up to 10. Sometimes it's used more as 9.81. That's depending on the question and will usually be specified within the question. They accelerate at negative g because usually we identify negative as the direction downwards, while positive as direction upwards. As again, air resistance is negligible, thus uniform acceleration occurs at all time. Hence, we can use the kinematic or the SVAD equations for all free fall questions. This gravitational acceleration can be found experimentally through measuring the displacement of a free falling object at time intervals, then calculating the instantaneous velocity and graphing velocity time graph. The slope of on this graph will be acceleration. We'll talk more about velocity time graphs and all of those graphs later on in this video. So now let's look at an example. A ball is dropped from the Empire State Building, which is 381 meters tall. How fast is it going when it hits the ground? So right away we can see it's a free fall question because you're dropping something and there's no air resistance. Otherwise it would be stated so. So what do we know? We know that acceleration equals -10 meters per second. We will just use -10 for the sake of simplicity of calculations. That's a given. The displacement of the fall will be 381 meters, as the tall is that big. However, it should be noted that it's a negative because we're going from up downwards. That's a given. And the initial velocity is 0. That's implicit. We want final velocity, or v. The formulas that we can use for this are as follows. Since we do not know the time of the fall, we can draw the first two equations which contain t, time ahead. That leaves us with final velocity squared equals initial velocity squared plus acceleration times displacement, which we'll use in our solution. Since the initial velocity is 0, that crosses it out completely. We just need to plug in a and s to give us final velocity of -87 meters per second.